Good evening everyone, good evening. I welcome you all again to NEET Elite. I hope you guys are doing great, having a good time. So people, you can let me know in the chats first of all if I'm audible and visible to everyone, right? Just let me know in the chats if I'm audible and visible to every single guy. Hello Chitra, hello Ashwarya, hello Dakshin, hello Tanzila, hello Ishpreet, welcome back, hi Kirtana, hello Urvija, hello Pragya. Hello Rehana, what's up? How are you all doing? Just give me a second guys, just give me a second, let me fix the things. Alright, hello Naresh, what's up? Hello Sushmita, hello Sana, hi Muskan, walaikum salam, hello Divya, hi Akash, hello Jitesh. Welcome back everyone to NEET Elite, and I hope you guys are doing great and having the good time at home as well. So people, in the tonight's session, we are going to continue with the Redox Reactions chapter. We were discussing about the n-factor calculations and we have done the majority part of the n-factor calculations, right? What we are going to talk about in the tonight's session, we are going to discuss some more n-factor calculations, and with that, we'll enter into the equivalent concept as well, yeah? What you call as redox titrations, okay? So before starting the session, the ones who have just joined in, who are new to the channel, let me introduce myself. Well people, my name is Wassim Sir and I'm your chemistry master teacher right here on this NEET Elite channel, yeah? The ones who have not liked the video yet, please do like the video, share the video with your friends, do subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this NEET Elite channel, right? So do like the video, share the video with your friends, and do subscribe to the channel as well. Yes, Ayan, these are sufficient. Yes, exactly. I'm doing great, Sana. How are you? Perfect, guys. I'm doing great, Ishpreet. Thank you. All right, so people, you can first of all let me know in the chats if you guys are super duper excited about the tonight's session as well. Yeah, right? Yes, after this chapter, I'll be doing the periodic classification, then chemical bonding, then again chemical equilibrium, ion equilibrium, and so on, right? So just people, let me know in the chats if you are super duper excited about the tonight's session as well, right? Let me see the Josh of the session first. Hello Iram, how are you? Hello Mufida, hello Harshil. Welcome back everyone, welcome back. Okay, so let's get going then. Let's get started with the tonight's discussion, right? Well people, we already talked about the n-factor calculation in detail, but there are some cases which are left. Let's try to finish off with those cases which were left in the last session, right? So I'm starting with the n-factor of the compound in which oxidation state of one element increases and another element decreases, right? How do we calculate the n-factor of the substance in which oxidation state of one element increases and the other one that decreases, right? How do we calculate n-factor of that substance? Okay, let's try to see that. First of all, if I'll ask you what is the oxidation state of iron over here, what you simply are going to do, as I told you in the earlier sessions as well, just use that class 9th rule, that crisscross rule, right? The charge present on iron is simply going to be +3. The charge present on sulfur is simply going to be -2. Well, if I calculate the charge on iron, it's going to be x minus 2 is equal to 0. So x value will come out to be +2. So +2 is the oxidation state of iron right here. What about the oxidation state of sulfur? It's going to be x minus 4 is equal to 0, and the x value will come out to be +4. As simple as that, right? So first thing, I calculated the oxidation state of every element over here. I calculated the oxidation state of every element over here. Point number 1. Point number 2. Let's check what is happening to the oxidation states of this iron and this sulfur. See guys, oxidation state of iron is changing from +3 to +2. That means oxidation state of iron is decreasing, yeah? And oxidation state of sulfur, it's changing from -2 to +4, right? Oxidation state of sulfur, it's changing from -2 to +4. That means oxidation state of sulfur is increasing. How do we calculate n-factor for the substance in which oxidation state of one element increases and another one decreases simultaneously? How do we check its n-factor, right? What I'll be doing, I'll be calculating the change in the oxidation state for iron, which I'll be representing by N1. Then I'll be calculating the change in the oxidation state of sulfur, which I'll be representing by N2. Then I'll take the difference of the two. I'll do N1 minus N2 mod. Whatever is going to be the value of N1 minus N2 mod, that's going to be basically N factor of this substance. As simple as that, right? Have a look exactly. See guys, if I talk about iron, iron's changing its oxidation state from +3 to +2, right? So what is the change in the oxidation state of iron? This is the final oxidation state of iron. This is the initial oxidation state of iron. Let's calculate the change in the oxidation state of iron, which is final oxidation state of iron minus initial oxidation state of iron. The value comes out to be 1, right? This one is the change in the oxidation state for one atom of iron, but currently I have got some 2 atoms, so I'm multiplying this with 2, so I got the N1 value as 2, right? N1 value over here I got as 2, right? Now, let's calculate the change in the oxidation state for sulfur as well. Well, this is the final oxidation state of sulfur, and this is the initial oxidation state of sulfur. Let's calculate the change. Final oxidation state of sulfur, that's +4, minus initial oxidation state of sulfur, that's -2. The value over here comes out to be 6, but this 6 is the change in the oxidation state for one atom of sulfur, but currently I've got some 3 atoms, so 6 multiplied by 3 is 18, right? So this is the value of N2 which I got, right? And this compound, it falls into the category in which oxidation state of one element increases and another one decreases. How do we calculate N factor of such substance? It's going to be mod of N1 minus N2, as simple as that, right? What is N1 value? That's 2. What is N2 value? That's 18. So I must say N factor of this species over here, it's going to be 16, right? Well, if you got to know its N factor, you can easily calculate its equivalent mass. How come you'll be doing that? Molar mass of this substance divided by its respective N factor, right? As simple as that. Absolutely, guys. Okay. Let me take a few more cases so that you can understand this concept clearly, right? Okay. We are given with a reaction in which we are supposed to calculate the N factor of this compound, BaSCN whole twice, right? We are supposed to calculate the N factor of BaSCN whole twice. How we are going to do that? How we are going to do that? See guys, exactly how we are going to do that. First of all, I'll be calculating the oxidation state of every element in this reaction. Let's calculate the oxidation state of every element in the reaction. After getting to know the oxidation state of every element in the reaction, then I'll see which elements are showing change in the oxidation state, right? Okay, that's something which I'll be doing basically. Understand what I'll be doing. If you remember, I've already shown you what is going to be the structure of BaSCN whole twice. Well guys, this is the structure of BaSCN whole twice, if you remember. What about the structure of HCN? Structure of HCN is simple. It is HC triple bond N. This is the structure of HCN, correct? Now understand. If you look at this carbon triple bond nitrogen, I must say nitrogen is more electronegative, due to which nitrogen is going to attract all the 3 bonded pair of electrons towards itself, due to which it shows -3, and at the same time carbon shows +3, right? Okay. If you look at this bond between sulfur and carbon, sulfur is more electronegative, so sulfur will attract this bonded pair of electron towards itself, due to which it gets -1, and carbon at the same time gets +1, as simple as that. Similarly, if you look at this bond between barium and sulfur, sulfur is more electronegative, so -1, barium shows +1. Simply, single bond between sulfur and barium, it's going to be -1, this again going to be +1. What about this single bond, sulfur and carbon? Sulfur is more electronegative, so -1, carbon at the same time will show +1. Due to this triple bond, as you know, nitrogen is going to show -3, carbon is going to show +3, right? Well, people, I must say the oxidation state of nitrogen over here is going to be -3. The oxidation state of carbon over here is going to be +4. The oxidation state of sulfur over here is going to be -2, right? And oxidation state of barium right here, it's going to be +2, correct? Well, I got the oxidation states of all the elements present in this compound, right? Oxidation state of barium came out to be +2. Oxidation state of sulfur came out to be -2. Oxidation state of carbon came out to be +4. And oxidation state of nitrogen came out to be -3. Well, these are the oxidation states of all the elements present in this compound, right? Okay. Now, if I talk about this barium, barium again will show over here +2 oxidation state, and sulfur is going to show +6 oxidation state when you will calculate it. And oxygen, I've got nothing to do with that, it will show -2 oxidation state, right? What about the oxidation states of each element in HCN, right? Look at this triple bond first of all between carbon and nitrogen. Nitrogen being more electronegative, so -3. Carbon at the same time will show +3, right? Between carbon and hydrogen, carbon is more electronegative. So carbon will show -1, at the same time hydrogen will show +1. What is the oxidation state of nitrogen over here? You'll say oxidation state of nitrogen is -3. What is the oxidation state of carbon over here? +3 minus 1 will come out to be +2. So +2 is the oxidation state of carbon over here. As simple as that. And similarly, oxidation state of hydrogen, it's going to be +1, right? Now we will understand few important things right here. Is the oxidation state of barium changing? Over here, the oxidation state of barium is +2, right? Over here, again, the oxidation state of barium is +2. Oxidation state of barium is not changing at all, right? So I've got nothing to do with barium. Now, let's see exactly, is the oxidation state of nitrogen changing? Nitrogen over here is showing -3 oxygen state. Right here, again, nitrogen is showing -3 oxygen state. So oxidation state of nitrogen is again not changing at all, right? But the oxidation state of sulfur is changing from -2 to +6, and oxidation state of carbon is changing from +4 to +2, right? Now you need to exactly look it out. See, -2 to +6, oxidation state of sulfur is increasing. +4 to +2, oxidation state of carbon is decreasing. So basically this compound falls into the category in which oxidation state of one element increases and another one decreases. How do we calculate N factor of such substance? It's going to be again mod of N1 minus N2, right? As simple as that. So first of all, I'll be calculating the change in the oxidation state of sulfur. Let's calculate the change in the oxidation state of sulfur, which I'll be representing by N1, right? It's going to be equal to final oxidation state of sulfur minus initial oxidation state of sulfur. The value will come out to be 6 plus 2 comes out to be 8. But this 8 is the change in the oxidation state for one sulfur atom. This 8 is the change in the oxidation state for one sulfur atom. But currently I've got two sulfur atoms, so I'm multiplying this term with 2. The value comes out to be 16. So I got to know the N1 value, which is 16, right? Similarly, let's calculate the N2 value as well, right? What is N2? N2 is nothing. It is the change in the oxidation state of carbon, which is final oxidation state of carbon, that's +2, minus initial oxidation state of carbon, that's +4. The value comes out to be 2 exactly. Let me tell you, this 2 is the change in the oxidation state for one atom of carbon, but currently I've got two atoms, so 2 multiplied by 2 is 4. I got the value of N1, I got the value of N2, right? Well, if you got to know the value of N1 and N2, how you are going to do it? You are simply going to get the N factor of this substance as mod of N1 minus N2, right? N1 value you got already, that's 16, and N2 is 4. So 16 minus 4 comes out to be 12. So you got to know the N factor of this BaSCN whole twice over here, right? And once you got to know the N factor of this substance, you can easily calculate its equivalent mass. How come? Its molar mass divided by its N factor, as simple as that, right? So first of all, you can let me know in the chats if it is clear to everyone so that I can move on and talk about a few more important things. Let me know in the chats fast. Perfect. Absolutely. Wonderful. Wonderful, guys. Let's move on and let's talk about the N factor of the substances which undergo disproportionation, right? N factor of the substances which undergo disproportionation. Now the point is, what is disproportionation all about? Understand what I'm going to talk about. People, can you see any charge present on this bromine over here? No, I must say its oxidation state is 0. Well, I want you guys to calculate the oxidation state of this bromine as well. It's going to be x minus 6 is equal to -1. So the value of x will come out to be +5, right? What about the oxidation state of this bromine over here? It's going to be -1 because the charge present on it is -1. As simple as that, right? Absolutely. Now guys, have a look exactly how I'll be trying to solve this question. See, first thing which you must understand right here. Oxidation state of bromine is changing from 0 to +5. That means in this part, the oxidation state of bromine is increasing. At the same time, oxidation state of bromine is changing from 0 to -1. So oxidation state of bromine is decreasing, right? Okay, oxidation state of bromine is increasing as well as decreasing simultaneously, right? Whenever I'll be having such kind of a case in which oxidation state of a particular substance simultaneously increases as well as decreases, we say the substance undergoes disproportionation. We say the substance undergoes disproportionation, right? Right? And that reaction in which any substance undergoes disproportionation, that's what we call as the disproportionation reaction. As simple as that, right? Okay. Let's exactly see how do we calculate the N factor of the disproportionation reactions, right? Simple guys, again I'm going to give you one trick, you're going to follow that. You'll be getting to know n factor of this substance which is undergoing disproportionation, and once you get to know its n factor, you can easily calculate its equivalent mass as well, right? So it's simple. I'll say n factor of Br2 in this reaction, n factor of the substance which is undergoing disproportionation, it's going to be equal to N1 N2 divided by N1 plus N2, right? Now what is N1? N1 is the change in the oxidation state in this part, N2 is the change in the oxidation state in this part, right? See guys, let me calculate the N1 value. Well, this is the initial oxidation state of bromine and this is the final oxidation state of bromine over here. Let's calculate change. It's going to be 5 final oxidation state minus initial oxidation state. The value comes out to be 5. But this 5 is the change in the oxidation state for one atom of bromine. But currently I've got 2. So 5 multiplied by 2 comes out to be 10. So people, I got the value of N1, right? N1 value I got to know the change in the oxidation state of bromine in this above part, right? Now, let's calculate the change in the oxidation state of bromine in the below part as well, which I'm representing by N2, which is again going to be final oxidation state of bromine, that is -1, minus initial oxidation state of bromine, that's 0. The value comes out to be 1. This 1 is the change in the oxidation state for one atom of bromine, but I've got 2 atoms of bromine. So 1 multiplied by 2 comes out to be 2, right? So you exactly got the value of N1 and N2. And we already know how to calculate the n factor of the species which undergoes disproportionation. It's simply going to be N1, N2 divided by N1 plus N2. Well, N1 value you know, N2 value you know, divided by N1 plus N2, right? So it's going to be 20 divided by 12. So it's going to be 5 divided by 3. So 5 divided by 3 is going to be the n factor of this Br2 in this particular reaction, right? And once you got to know its n factor, you can easily calculate its equivalent mass by simply dividing its molar mass by its respective n factor. I'm sure it's clear to everyone, right? You can let me know in the chats if every single thing is clear. Yeah? Exactly, guys. Perfecto. Wonderful. Let me take one more case. In which this P4 is undergoing disproportionation. See guys, what is the oxidation state of phosphorus over here? It's 0. What about the oxidation state of phosphorus right here? It's going to be -3 when you calculate it. X plus 3 is equal to 0, so X value will come out to be -3, right? Let's calculate the oxidation state of phosphorus in this compound as well. See, hydrogen is going to show +1 oxygen state, and you have got 2 hydrogens. Let the oxidation state of phosphorus be X. Oxygen shows -2 oxygen state, and you have got 2 oxygen atoms, right? You have got 2 oxygen atoms. Net charge is -1, right? Okay, so I think it's done, right? It's +2 plus X minus 4 is equal to -1. So you can say X minus 2 is equal to -1, or you can say X is simply going to be equal to +1. So +1 is basically the oxidation state of this phosphorus, right? Yeah, as simple as that. Now understand. Oxidation state of phosphorus is decreasing in this part, and oxidation state of phosphorus is increasing in this part, right? Oxidation state of phosphorus is decreasing in this part and increasing in this part. So I'll say this P4 is undergoing disproportionation, right? And we already know whenever a substance undergoes disproportionation, how do we calculate its n factor? It's going to be N1 N2 divided by N1 plus N2, as simple as that, right? Now let's try to get the value of N1 and N2. N1, change in the oxidation state of phosphorus, final oxidation state minus initial oxidation state, value will come out to be 3. 3 is the change in the oxidation state for one atom of phosphorus, but I have 4, so 4 multiplied by 3 is 12, so N1 value is 12, right? Similarly, calculate the change in the oxidation state of phosphorus again, final oxidation state minus initial, value comes out to be 1. 1 is the change in the oxidation state for one atom of phosphorus, but I have 4, so N2 value will come out to be 4 only, right? So people, you got N1, you got N2, so it's going to be 12 multiplied by 4 divided by 12 plus 4, right? It's going to be 48 divided by 16, the value comes out to be 3, and 3 is basically going to be the n factor of this P4 in this reaction, right? Yeah? Well, if you got to know the n factor of P4 in this reaction, you can easily calculate its equivalent mass as well. How come? Molar mass of this substance divided by n factor of this substance, as simple as that, right? You can give me some confirmation in the chat box if it is clear so that I can move on. Right? Or let's try to solve one more. Let me give you one reaction. H2O2, it gives H2O plus O2. I want you guys to let me know the n factor of this H2O2 in the reaction. Yeah? I want you guys to calculate the n factor of H2O2 in this particular reaction. Give it a try. Give it a try, guys. Thank you, Erwin. That's great. Monish, I think in the tonight's session only, we'll be starting with the redox titration, yeah? Let's see where we are going to reach. So Arzu Fayaz is coming up with the answer as n factor of H2O2 is equal to 1. Ishpreet is coming up with 1 as well. Yeah? Ashika, n factor of KMnO4 and K2C or 2O7 in acidic medium, it's different, it's not same. N factor of KMnO4 in acidic medium is 5 and n factor of K2C or 2O7 in acidic medium, that's 6. Yeah? Alright, let's give it a try, guys. See, what about the oxidation state of oxygen in hydrogen peroxide? It's going to be -1. Oxidation state of oxygen over here is going to be -2. Oxidation state of oxygen right here is going to be 0, right? See, -1 to -2, decrease in the oxygen state. -1 to 0, increase in the oxygen state. So I must say this H2O2 is undergoing disproportionation, right? So how will I be calculating its n factor? N factor of H2O2 is going to be equal to N1 N2 divided by N1 plus N2, right? What is the N1 value? Calculate the change in the oxidation state of oxygen in the above part. -1 to -2. -1 to -2. Calculate the change. Change in the oxidation state of oxygen is going to be final oxygen state minus initial. The value comes out to be 1, right? 1 is the change in the oxidation state for one atom of oxygen, but I have 2 atoms. So N1 value is 2. N1 value is 2. What about N2? -1 to 0. Calculate the change. 1 is the change for one atom of oxygen, but out 2. So N2 value is also 2. So 2 multiplied by 2 divided by 2 plus 2, the value comes out to be 1. Exactly, you all are right. N factor of H2O2 in this reaction is going to be 1 exactly. Yeah? Okay. And people, in the earlier cases, if you remember, I told you in the last session, H2O2 is that compound which sometimes can act like the oxidizing agent, sometimes it can act like the reducing agent. Remember? When H2O2 acts as a reducing agent, its n factor will be taken as 2. When it acts as the oxidizing agent, its n factor again is going to be taken as 2. We have seen these reactions as well. And when H2O2 undergoes disproportionation, its n factor will be taken as 1, right? Okay? Yeah? Perfect. Is that clear to everyone? You can let me know in the chats. Ganesh, on the actual Vedantu platform, I take Drishti NEET B batch. Drishti NEET B batch I take, right? And that's basically Hindi batch. In that batch, I do not take class in English, I take class in Hindi. That's a complete Hindi batch. Okay? I think it's perfectly done, right? So, should we move on? Absolutely. Let's move on. So, I'm sure now you guys are clear with something called as equivalent mass. Now you guys are, now you can calculate the equivalent mass of any species, whatever comes, right? I think you're done with that, right? Only these n factors you need to remember, and you need to remember basically how to calculate n factors of different species, right? And we have done it in detail. Perfect? Right. Okay. Perfect. Now let's move on to something called as equivalent concept, and in the equivalent concept, let's get to know about something called as number of gram equivalents, right? Let's get to know the number of gram equivalents. Before talking about this term, number of gram equivalents, before talking about this term, let me tell you this in short. Understand? People, what is the basic formula to calculate number of moles of any substance? Can you let me know fast in the chats? What is the basic formula to calculate number of moles of any substance? Basic formula is given mass of the substance in grams divided by molar mass of the same substance. Divided by molar mass of the same substance, right? This is the basic formula to calculate the number of moles. Now people, in this formula, what I'll be simply doing, I'll be removing molar mass of the substance from the denominator. And instead of molar mass of the substance, what I'll be doing? See, I'll be writing it like this. Given mass of the substance in grams divided by. Instead of molar mass of the substance, I'm writing equivalent mass of the substance. Right? When I divide the molar mass of the substance by its respective equivalent mass, I'll be calling this term now as number of gram equivalents. I won't be calling it as the number of moles, I'll be calling it as the number of gram equivalents. Yeah? I'll be calling it as the number of gram equivalents, correct? Right? See, in the above formula, if I remove this term in the denominator and instead of molar mass of substance, I'll be keeping equivalent mass of the substance, then I won't be calling it as the number of moles of the substance. I'll be calling it as the number of gram equivalents of the substance, right? Formula number 1, which I want you guys to remember. Yeah? Now guys, have a look. Number of gram equivalents of the substance is equal to given mass of the substance in grams, which I'm representing by W, divided by equivalent mass of the substance. As you all must be familiar with the fact, equivalent mass of the substance is nothing, that is molar mass of the substance divided by n factor of the substance. So that n factor will come up, right? What about this term? What is this term all about? Given mass divided by molar mass. Given mass divided by molar mass. We call this term as number of moles, right? So I got one more result, which I want you guys to remember. Number of gram equivalents of the substance is equal to number of moles of that substance multiplied by n factor of the same substance, right? This one more result which I want you guys to remember. These are two important results to calculate the number of gram equivalents. To calculate the number of gram equivalents, right? Okay, I'm sure you're clear with these two results. Yeah? Whenever you'll be supposed to calculate the number of gram equivalents, you can use this result, given mass of the substance divided by equivalent mass of the substance, or you can use this result, number of moles of the substance multiplied by n factor of the substance. As simple as that, right? Now comes one more term. What is that term all about? That's called as number of milli-equivalents. Number of milli-equivalents. Remember, number of milli-equivalents is nothing. That means number of gram equivalents multiplied by 1000. This is something which we call as number of milli-equivalents, right? Number of gram equivalents multiplied by 1000, or you can make its relation as well. I can say number of milli-equivalents is equal to number of gram equivalents is going to be equal to given mass of the substance in grams divided by equivalent mass of the substance multiplied by 1000. This is one more result which I want you guys to take a note of, right? Number of milli-equivalents, given mass of the substance divided by equivalent mass of the substance multiplied by 1000, right? Okay, this one more result, correct? Now talking about one more result. You can say number of milli-equivalents. Number of milli-equivalents is equal to. Number of milli-equivalents is equal to. I can say number of milli-equivalents is equal to number of millimoles of the substance, right? Number of millimoles of the substance multiplied by n factor of the same substance. One more result which I want you guys to remember. Number of milli-equivalents of the substance is equal to number of millimoles of the substance multiplied with n factor of the substance. Now the point is, what is number of millimoles of the substance? Number of millimoles of the substance is nothing. I'll say number of millimoles of the substance is always equal to number of moles of the substance multiplied with 1000. That's all, right? This is number of millimoles. Number of moles of the substance multiplied by 1000, right? I'm sure every single thing is clear till here, right? People, these are some important formulas which I want all of you to take a note of, because I'll be needing these formulas in the redox titration directly, okay? Perfect. Should I move ahead, guys? Should I move ahead? Have you taken a note of every single thing over here which I mentioned? Yeah? All right. Perfectly done then. Okay, now let's move on then. And let's try to solve a simple question over here. Calculate the number of gram equivalents in 31.6 grams of KMnO4 in acidic medium. A very simple and basic question, right? See, I'm given with the mass of KMnO4, which is 31.6 grams. And this KMnO4 is participating in an acidic medium, right? In acidic medium. If you remember, I've told you, whenever KMnO4 participates in the acidic medium, it gets converted into Mn di positive, right? I hope you remember. In acidic medium, we have discussed it in detail, right? And anyways, we already know n factor of KMnO4 in acidic medium. N factor of KMnO4 in acidic medium, that's going to be 5. That's something which we have discussed in detail as well, right? What do I need to calculate as per the question? Calculate the number of gram equivalents in 31.6 grams of KMnO4. So I'll write number of gram equivalents of KMnO4 is going to be equal mass of KMnO4 in grams divided by equivalent mass of KMnO4, right? Mass of KMnO4 in grams, that is 31.6 grams, divided by equivalent mass of the substance, equivalent mass of KMnO4, that's going to be equal molar mass of KMnO4, which is 158 grams, divided by n factor of KMnO4, that's 5, right? So you need to solve it, you'll be getting the value over here as 1, right? So 31.6 grams of KMnO4 in acidic medium, it means that he is talking about 1 gram equivalent of KMnO4, right? It simply means he's talking about 1 gram equivalent of KMnO4. Yeah? So this is how you basically calculate the number of gram equivalents of any substance, right? Simply by dividing the given mass of the substance by its respect to equivalent mass, you'll be absolutely getting what? You'll be getting the number of gram equivalents. If I'll ask you, what is going to be the value of number of milli equivalents of KMnO4? You will clearly say number of milli equivalents of KMnO4 is going to be equal number of gram equivalents of KMnO4 multiplied with 1000, right? Gram equivalents we have calculated as 1 multiplied with 1000. So this is going to be the number of milli equivalents of KMnO4 in acidic medium, right? Number of milli equivalents present in 31.6 grams of KMnO4 in acidic medium, right? I'm sure it's clear to everyone. Perfect. Right, guys? Yes, Hari Kishore, you can do that absolutely. Why not? Sajja, few minutes back only, I've shown you that question. How to calculate the N factor of H2O2 in the disproportionation reaction. Just drag the video a little back. I've shown it in the beginning only, right? Not in the beginning, just right after 10-15 minutes of the starting of the video. I've shown you. N factor of H2O2 in disproportionation is 1. Yeah? Yes, Selvan, these are enough. Absolutely, these are enough. Thank you, Rahul. Thank you so much. Okay, so should we move on then? Should we move on? No, Sukrit, you cannot say that. All right, let's move on then. Let's talk about something called as normality. Let's talk about something called as normality. Should we do the normality first or should we do the balancing of redox reactions first? I'm keeping the ball in your court. Let me know. You want me to do the normality first or balancing first? Balancing, is that? Well, I can see majority of the students are coming up with the balancing, right? So let's try to do the balancing first. Let me show you exactly how do we balance the reactions, and then maybe in the next session we'll be talking about the normality of the reaction and the redox titration, equivalent concept, yeah? Okay, all right, fine. Let's see exactly how do we balance the redox reactions, right? Balancing of redox reactions. It's a very simple topic, balancing of redox reactions, right? Well, let me tell you, there are two methods by means of which we can balance the redox reactions, right? As per your NCERT is concerned. One is called as the ion electron method. One is called as oxidation number method. There are two methods by means of which we can we can balance the redox reactions. One is going to be ion electron method. One is called as oxidation number method. Now, ion electron method, it is done in acidic medium separately, and in basic medium, it's done separately, right? In acidic and basic medium, it's done separately. Similarly, oxidation number method, in acidic and basic medium, it's done again separately. In acidic and basic medium, it's done separately, right? Okay. Perfect. So basically we are going to study ion electron method, balancing of redox reactions by ion electron method in acidic medium. Then we'll be talking about the balancing of redox reactions through ion electron method in basic medium. And later on we'll be discussing about the balancing of redox reactions through oxidation number method in acidic medium and then in basic medium separately, right? Let me take the question directly, right? Okay, let me take a reaction generally. Okay, let me take the reaction directly. I'll show you exactly how do we balance the reactions, right? A very simple topic this is. First of all, let me get some reactions. Have a look. Just a second, guys. Just a second. Let me take certain reactions. Okay, the first reaction which I'm taking over here, we have discussed this reaction as well. I'm writing a reaction MnO4 negative plus I negative, MnO4 negative plus I negative, MnO4 negative plus I negative in acidic medium. H positive represents acidic medium, gets converted into Mn di positive plus I2. This is the reaction that's given to me. This is the reaction that's given to me, and this reaction is taking place in acidic medium, right? Now let me show you first of all, how do we balance this reaction through ion electron method in acidic medium, right? Okay. First thing which I'll be doing over here, I'll be calculating the oxidation state of every element. Oxidation state of manganese right here is going to be +7, right? Oxidation state of this I negative, it's going to be -1 because the charge present on it is -1, right? Oxidation state of Mn over here is going to be +2. Oxidation state of iodine over here is going to be 0, right? I calculated the oxidation state of every element, yeah? Now exactly have a look what I'll be doing. Well, people, have a look exactly. Is the oxidation state of manganese increasing or decreasing? +7 to +2. Oxidation state of manganese is decreasing. Decrease in the oxidation state is what we call as a reduction. So I can say this MnO4 negative in this part is undergoing reduction, right? Similarly, iodine is changing its oxidation state from -1 to 0. -1 to 0, increase in the oxidation state. Increase in the oxidation state is what we call as oxidation. So I can say this I negative is undergoing oxidation. This I negative is undergoing oxidation, right? So first thing which I'll be doing over here, I'll be breaking the reaction into two parts. I'll be breaking this reaction into two parts. One I'll be calling as oxidation half reaction, and one I'll be calling as the reduction half reaction. What is oxidation half reaction all about? In case of oxidation half reaction, your I negative is getting converted into I2, right? I negative is getting converted into I2. This is the oxidation half reaction, but it's not the perfect oxidation half reaction. Why is that? Let's make it perfect. Have a look exactly. See, this is the oxidation half reaction. I negative is undergoing oxidation. Oxidation simply means loss of electrons, right? Oxidation simply means loss of electrons. Yeah? People, as you all must be knowing, if I'll be having one I negative, when it loses one electron, it gets converted into iodine, correct? But over here, I2 is getting formed. So I should start with two iodide atoms. I should start with two iodide atoms. Two iodide atoms are going to lose two electrons, then only they'll get converted into I2. As simple as that. So what is my actual oxidation half reaction? I negative, it's going to be 2 times I negative, gives I2 plus 2 electrons. This is my oxidation half reaction, right? Similarly, I'll be writing the reduction half reaction as well. I'll be writing the reduction half reaction as well. Which compound is undergoing reduction? MnO4 negative is undergoing reduction. MnO4 negative is undergoing reduction. It is getting converted into Mn di positive. It's getting converted into Mn di positive. What about the oxidation state of Mn over here? +7. Oxidation state of Mn over here? +2. +7 to +2, decrease. Decrease in the oxidation state is what we call as reduction. Reduction means gain of electrons, right? So in this reaction, gain of electrons will be happening, right? In this reaction, gain of electrons will be happening. Calculate the change in the oxidation state. Final minus initial. 5 is the change in the oxidation state. That means this MnO4 negative will be gaining some 5 electrons, then only it will be getting converted into Mn di positive, right? This was my oxidation half reaction. Now this is my reduction half reaction, right? After writing the oxidation and reduction half reactions, after writing the oxidation and reduction half reactions, what am I supposed to do? What am I supposed to do? What I'll try to do is, I'll try to balance these electrons. I'll try to make these electrons equal in both the reactions. And how will I be doing that? I'll be multiplying this reaction by 5. I'll be multiplying this reaction by 2, right? When I multiply first reaction by 5, it becomes 10 times I negative. It becomes 5 times I2. Just a second. It becomes 5 times I2, and this becomes 10 electrons over here. Similarly, I multiplied the second reaction by 2. So this becomes 2 times, this becomes 10 electrons, and this becomes 2 times. Well, if you can see right here, I made the electrons equal in both the reactions, right? After making the electrons balanced in both the reactions, I'll be simply adding them up. I'll be simply adding them up. Let me add the left-hand side and our right-hand side separately. Left-hand side is going to be like 10 times I negative plus 2 times MnO4 negative. 2 times MnO4 negative. It gives 5 times I2 plus 2 times Mn di positive. This is the reaction which I got, yeah? And 10 electrons got cancelled out, right people? Now, after writing this reaction, after adding these two reactions, since the reaction is taking place in acidic medium, we always try to balance oxygen first. And in order to balance oxygen atoms, you will be adding the requisite number of H2O, water molecules. What is meant by that? Have a look. On the left hand side, how many oxygen atoms do we have? On the left hand side, we have got 8 oxygen atoms. On the right hand side, I do not have any oxygen atom. So in order to balance 8 oxygen atoms, I'll be adding 8 water molecules on this side, right? Oxygens are balanced. After balancing the oxygen, let's try to balance the hydrogens. Is there any hydrogen on left hand side? There is no hydrogen on left hand side, but there are some 16 hydrogens on right hand side, and in order to balance the hydrogens in acidic medium, you'll be adding H positive ions. Since on right hand side there are 16 hydrogens, so I'll be adding 16 H positives on the left hand side. This reaction would have got automatically balanced. It's a balanced chemical equation now. It's a balanced chemical equation. Let me know in the chats if it's clear to everyone. Let me know first. Clear to everyone? Right, people? Let me give you one more example of balancing the redox reaction in acidic medium through ion electron method, right? Let me give you one more example so that you can exactly master it, okay? For example, I'm writing the reaction like this. MnO4 negative plus Fe di positive. It gives Mn di positive plus Fe tri positive. And this reaction is, for example, taking place in acidic medium, and I need to balance this reaction by ion electron method. Ion electron method. Again, I'll be using the same steps, right? Again, I'll be doing the same steps. See, first thing, calculate the oxidation state of manganese right here. It's +7, right? Calculate the oxidation state of iron right here. It's +2. Oxidation state of manganese over here, it's again +2. Oxidation state of iron right here, it's +3, right? I calculated the oxidation states of all the elements over here in this reaction, right? Now I'm going to break this reaction into two parts, right? One is going to be oxidation half, one is going to be reduction half, right, people? So first of all, let me write the oxidation half reaction. How do I get the oxidation half reaction? See guys, Fe di positive is getting converted into Fe tri positive. So the oxidation state of iron is increasing. Increase in the oxidation state is what we call as oxidation. So what is going to be my oxidation half reaction? It's going to be Fe di positive gets converted into Fe tri positive, right? This is my oxidation half reaction. Di positive to tri positive. Increase in the oxidation state. +2 to +3. Increase in the oxidation state means oxidation. Oxidation means loss of electrons. How many electrons are being lost by this Fe di positive? Calculate the change in oxidation state. Final minus initial. Value comes out to be 1. So 1 electron is being lost by Fe di positive. Then only it gets converted into Fe tri positive, right? As simple as that. Yeah? Now if I talk about the reduction half reaction, I'll first of all see which compound, which species is undergoing reduction. +7 to +2. Decrease in the oxidation state. That's reduction. Reduction means gain of electrons. So you got to know MnO4 negative, it's first of all getting converted into Mn di positive, right? Okay, so +7 to +2. What is the change in oxidation state? 5. Okay, and this is a reduction reaction. It's a reduction of reaction. Reduction means gain of electrons. So how many electrons are being gained? 5 electrons are being gained, right? I got the oxidation of reaction. I got the reduction of reaction. Now what is the next point? I'm supposed to balance these electrons in both the sides, right? Over here we have got some 5 electrons, right here we have got only 1 electron. So I'll be multiplying first reaction by 5. If I multiply first reaction by 5, this should be 5 times. This is going to be 5 times. And this is going to be 5 times as well, right? Electrons are balanced. After balancing the electrons, what I'll be doing? I'll be adding the two reactions up, yeah? Bharti, there is something called as dragging the video a little back. You can drag the video a little back, it'll be a replay for you. Use your common sense a bit, okay? See. Now what I'll be doing, I'll be adding the two reactions. I'll be adding the LHS part separately, RHS part separately, right? See guys, so it's going to be 5 times Fe di positive plus MnO4 negative. MnO4 negative, it gives 5 times Fe tri positive, right? Plus Mn di positive. This is the reaction which I got after adding these two reactions up, yeah? Right? Now people, first thing, since the reaction is taking place in the acidic medium, and in the acidic medium we balance oxygen atoms first by adding the water molecules, right? By adding the water molecules, correct? How many oxygens do we have on the left hand side? 4. Is there any oxygen on the right hand side? No way. No, there is no oxygen on the right hand side. So I need to add some 4 water molecules in order to balance the oxygen atoms. Now check it out. Are the oxygens balanced? Oxygen atoms are balanced, right? Now after balancing the oxygen atoms, it's time to balance the hydrogens. On the right hand side, we have got some 8 hydrogens. On the left hand side, there is no hydrogen. In order to balance the hydrogen atoms, what do? We add H positive ions. We have got 8 hydrogens on the right hand side. So I'll be adding some 8 H positives on the left hand side. I'll say this reaction is balanced. This reaction is balanced, right? Perfect, guys. Is it clear to everyone? Yeah? I think this must be clear to everyone, right? Right, people? Let me know in the chats if it's clear. Yes, future medicos, you can let me know what the doubt is. Got it? See, on the right hand side, you have got some 8 hydrogens. In order to balance 8 hydrogens, we need to add 8 H positives to balance the hydrogen. That's all, right? Okay, this was how do we balance the reaction? By ion electron method in acidic medium, right? Yeah? Yes, Ganesh, you need to solve that. You need to solve that. Now let's see the same ion electron method in basic medium, right? Let's see the same ion electron method in basic medium. Let me take certain reactions so that you understand properly. Just a second. So first of all, I'm making the heading over here as ion electron method in basic medium. In basic medium. Let me take one reaction and let me try to balance it. This is Cl2 plus iO3 negative. Cl2 plus iO3 negative. In basic medium, it gets converted into Cl negative, and with this you get iO4 negative as well. You get iO4 negative as well. I need to balance this reaction in which medium? In basic medium. Through which method? Through ion electron method, right? Okay. Now guys, first 2-3 steps are similar, right? The first 2-3 steps are similar. See, oxidation state of chlorine right here is 0. Oxidation state of iodine over here is +5. Oxidation state of chlorine right here is -1. Oxidation state of iodine right here is +7, right? So I got the oxidation states of all the elements. See now, understand. Break this reaction into 2 parts. One is going to be your oxidation half reaction and one is going to be your reduction half reaction, absolutely. See guys, +5 to +7, increase in the oxidation state. Increase in the oxidation state means oxidation. So what is going to be my oxidation half reaction? It's going to be iO3 negative. It's getting converted into iO4 negative, right? So from +5 to +7, increase in the oxidation state means oxidation. Oxidation means loss of electrons. So from +5 to +7, how many electrons are being lost? 2 electrons are being lost. Calculate the change in the oxidation state, final minus initial, right? This is my oxidation half reaction. Similarly, I'll be writing the reduction half reaction as well. What is my reduction half reaction all about? See, 0 to -1, decrease in the oxidation state means reduction. So Cl2 is undergoing reduction. Cl2 is undergoing reduction and then it's getting converted into Cl negative, correct? Now guys, you all must be knowing, if one Cl accepts 1 electron, it gets converted into Cl negative. But currently, do I have 1 Cl or 2 Cl atoms? We have got 2 Cl atoms. So 2 Cl atoms will be getting 2 electrons and they'll be getting converted into 2 Cl negative, right? Okay, I got the oxidation half, I got the reduction half. Now if I ask you, are the electrons balanced on both the sides? Yes, the electrons are balanced on both the sides. Let's add these 2 reactions up. So it's going to be iO3 negative plus Cl2. It gives iO4 negative plus 2 times Cl negative, right? Till now, I've solved the question, right? Now, if the reaction was supposed to be balanced in the acidic medium, after this step, we used to balance oxygens, right? But in basic medium, now we are not going to balance the oxygens first. We are going to balance the charge. And we are going to balance the charge by adding the OH negatives. How come that's possible? Understand. See guys, on this iO3, what is the charge present on this iO3? It's -1. There is no charge present on Cl2. What is the charge present on this iO4? It's -1. What is the charge present on this Cl? It's -1. On 1 atom of Cl, the charge present is -1. On 2 atoms of Cl, the charge present will be -2, right? So what is the charge on the left hand side? -1. What is the charge on the right hand side? -3. So on the left hand side, charge present is total -1. On the right hand side, charge is -3. So this is -1, this is -3. So on which side I need to add OH negatives? On which side I need to add OH negatives? On the left hand side, I'll be definitely adding the OH negatives, right? See, the net charge on the left hand side is -1. The net charge on the right hand side is -3. So over here on the left hand side, I'll be adding 2 OH negatives. Then only the charge gets balanced. Now after adding 2 OH negatives, you can check it out. The charge on both the sides is now going to be -3 only, right? Okay, the charge is balanced. After balancing the charge, now balance the oxygen atoms. And in the similar way, how many oxygens do we have on the left hand side? 3. 3 plus 2, 5. We have got 5 oxygens on the left hand side. On the right hand side, we have got 4 oxygens. 5 oxygens, 4 oxygens. So right hand side is oxygen deficient. And in order to balance the oxygens, we add the water molecules. So I'll be adding 1 water molecule over here, right? I'll be adding 1 water molecule over here, right? Now no need to balance H positives, no need to balance hydrogens. The reaction would have got automatically balanced. Your balanced charge, after balancing the charge, you balance the oxygen atoms. Your hydrogens would have got automatically balanced. You can check it out as well. 2 hydrogens on the left hand side and 2 hydrogens on right hand side as well. Yeah. One question I'm giving you as the homework, and you guys will be giving it a try and letting me know its answer in the comment section once the video ends, right? I'm making a question for you. The question is ClO2 plus H2O2. It gives ClO2 negative plus O2. The reaction is taking place in the basic medium, and you guys are going to balance this reaction through ion electron method. This is going to be your homework. Do let me know its answer in the comment section, right? So I think this much is enough for today. In the next session of the redox, which is going to be tomorrow, I'll be showing you the balancing of redox reactions through oxidation number method in both acidic and basic medium, and then we'll move on to the equivalent concept, which is what we call as redox titration, right? And before ending the session, let me tell you a few important things, right? Which I keep on telling after every session, right? So let me tell you guys, if you want to get enrolled in the actual Vedantu platform, right, which is taught by, right, if you want to get enrolled in the actual Vedantu platform, apart from these YouTube sessions, right, the actual Vedantu platform which I'm talking about, the batch for the class 11 students is going to start on 27th of September, right? The batch is going to start from 27th of September. That means from Monday, we are starting one more batch for you guys for NEET 2023 students on the actual Vedantu platform, in which you will be getting trained by the teachers of your choice. Point number 1. We'll be training you in all the 3 subjects, physics, chemistry, as well as biology, right? Okay. And people, this course, right, the batch which is starting on 27th of September, this batch will be with us for 2 years, right? And it's going to be your wish to select any of the plans and get enrolled, right? We have got 3 plans for you. Let me brief you about these 3 plans. The first plan is the light plan, which is valid for 2 years basically, right? And this much is the course fee for complete 2 years. But Vedantu has kept one option for you guys. You can pay this much of amount in EMI as well. Monthly EMI you can do, right? What all things you'll be getting in this one? You'll be getting live interactive online classes for all the 3 subjects, right? On the actual Vedantu platform, apart from these YouTube sessions, right? YouTube sessions are free, right? Okay, test series will be conducted, analysis will be there, notes and the study material. This is the best part, guys. Study material, Vedantu Tattva material, considered as one of the best across the country. You'll be getting that, right? And people, if you have no idea how the actual Vedantu platform looks like, you can do one thing. You can take this subscription for a month. You can take this subscription for a month. For 1 month, you need to pay this much of amount only, right? Okay. So you can just subscribe it. You can just go for it for a month, first of all, right? If you think you are getting benefited by the sessions, you can then go for the actual classrooms, right? Okay, and trust me, once you get enrolled in the Vedantu platform, right, for a month, you'll automatically get enrolled in the long-term course with us for 2 years. Trust me on that, right? There is one more, that's a classic program. It's again the 2-year classroom program. This much is a course fee. You can pay this much in EMI as well, right? Over here you get something extra, which is doubt solving on mobile app. Whenever you feel any sort of doubt, you can write your doubt on the app, and at the same time you'll be getting your doubts cleared by the teachers of your choice, right? And you can take this plan even for a month, right? If you are new to Vedantu, you have no idea how the actual Vedantu platform looks like, you can take the subscription for a month, right? And then after that, after taking the month, if you think you are getting benefited, then you can go for the actual program, right? And similarly, the last one, what is the Best part in the last one, you get personalized mentor in all the 3 subjects, physics, chemistry, as well as biology. You get personalized mentor in all the 3 subjects, right? That's why its price is comparatively higher, and it's a 2-year classroom program, right? And at the same time, if you want to go for a month, right? If you want to check it out for a month, you can pay this much of amount and get enrolled in this plus subscription for a month, right? And people, while enrolling, do not forget to use this coupon code of WSPRO, right? After using this coupon code, you'll be getting some additional 10-20% off, right? Okay. Now people, let me exactly show you how to get enrolled in this pro subscription. Before that, there's a link in the description box of the video. Click on this link, get added to the Telegram group and stay updated about the classes. And if you're not liked the video yet, please do like the video, share the video with your friends, and do not forget to subscribe to the channel, right? So people, let me show you exactly at the end how to get enrolled in the actual Vedantu platform, right? The batch which is starting on 27th of September, how to get enrolled in that. See, this is the video which you guys are currently watching, right? I'm dragging this video a little down. You need to click on this show more. After clicking on this show more, you'll be getting a lot of links, right? See, NEET 2-year batch link is here. Grade 11-12 science link is here. CBSE term 1 and 2 link is here. CBSE science term 1 crash course is available here. You can take any one of the links. For example, I'm selecting NEET 2-year crash. It's not the crash, NEET 2-year classroom program. Now over here, you can select any of the plans. Either you can go for light, or you can go for classic, or you can go for plus, right? For example, I'm going for light, okay? You'll be using the coupon code WSPRO, you'll be getting some additional 10% off, right? And people, over here you have got 2 options. Either you are going to buy the complete course, or you can try it out for a month. If, for example, I'm trying it out for a month, I'm clicking over here. After clicking over here, I'll be putting my number or email on which I'll be getting the OTP, right? And then only I'll be automatically getting enrolled into the actual Vedantu platform in the batch, which is going to start on 27th of September. That is on Monday by the teachers of your choice, right? So people, this was all from my side in the tonight's session. I'm going to see you guys tomorrow at the same time. Not at the same time. I will be seeing you tomorrow at 6 p.m. sharp, right? 6 p.m. sharp tomorrow, I'll be taking your session on this NEET Lead channel, right? In which I'll be discussing about the balancing. And at the same time, we'll be discussing about the redox titrations as well. So let's catch up tomorrow at 6 p.m. sharp. Till then, you guys can take care. Bye-bye. God bless you all. I love you all. Take care, guys. Bye. Welcome, Shreya. Thank you.